Hi, hello everyone. Welcome back for whoever was here. Thank you. For whoever was here last time, and welcome to whoever is new. And welcome to a new Papers We Love Milano. Okay, so this is a community that we're trying to bootstrap again. We started in 2019, 2020, and then you know what happened. So we're trying to make it work again. So this is our second meeting, and Loris Crow from Zig Foundation is with us tonight to introduce how to work with systems programming, why it's very important to learn systems programming even if you're doing very higher level programming. But what is it? What is Papers We Love Milano? It's a community to share papers with your friends, create a network of people that enjoy talking about computer science and connecting with academics, startups, and whatever. R&Ds and so on and so forth. So even if you're not an academic, even if you're just working a daily job and doing programming, this is an interesting place where to find hopefully interesting people to talk about computer science. So good news. Now we also have some sort of calendar for the next meetings. So on April, we still don't know. But probably at the end of month we will have something, so stay tuned. But for May 18, we already have someone coming as a friend of Loris, in fact. Guy Royce from Redis Labs is going to talk to us about probabilistic data structures. And last time we sent out a survey to people that attended, and a lot of people wanted to learn more about data structures, probabilistic data structures, and distributed data structures. This should be interesting for them. And so we don't have a date yet, an exact date yet, but probably it will be on June 8 or 9, something like that. Hopefully not on the 7th. I won't be there, but someone will be there. Alessandra, friend of Lucas, is going to talk about a paper they published, OncoLoop, a network-based precision cancer medicine framework. So this is a very interesting topic, kind of dear to me. Precision medicine is kind of the intersection between medicine and programming. And it's not just programming in medicine, it's a very specific niche. So it's going to be a very interesting talk because it will be both interesting for people that do programming and computer science, but also people that work in life science. So if you have friends that work in life science, biologists, doctors, etc., please do tell them about this talk because it's going to be a lot of fun. So yeah, that was basically it. Oh yes, if you want to stay connected with us, there's this QR code for the GitHub, and there's Twitter, there's the Eventbrite, and we don't have a Mastodon yet. Probably gonna create one in a while. I'm not gonna pay the $8. There we have a Discord. This should work. This is an invite that should work. If it doesn't, just let me know. And if you would like to do a presentation, or you have friends that would like to do a presentation, or you would like to, I don't know, host the meeting, although we do like the Dreams Tech Lab, let us know. We're here for you, and that's it. Thanks. Let's give a round of applause for Loris, and here's to him. Thank you.
Okay, can everybody hear me? Yes. Okay, thank you, Eduardo. So let me switch to my slides. Okay, hello everybody. My name is Loris Crow, and yes, I work at the Zig Software Foundation, which is a non-profit foundation that makes a programming language, a systems programming language. And guess what? Surprise, surprise, I'm here to talk about systems programming. Let me put it this way. this talk is not exactly about a paper. It's a bit of a meta talk, if you will. It's about papers, not a paper, but papers. And more in general, I think it's about what also is behind papers. It's that it goes past papers. The idea that you want to improve, you want to get better, you want to discover new interesting ideas. And my argument is going to be that systems programming, despite not having the best of not sounding super interesting by itself to most people, is an interesting gateway to interesting ideas. And it's and things are getting easier and easier from that perspective. That's what I'm going to talk about with this talk. Also, this is not just from the perspective of somebody who reads paper, but it's also about, I think, what we actually do during our day, which is web development, making distributed systems. So I'm going to ask you in a moment also how many of you actually do that in their day job. Last thing on me before I start, I run Software You Can Love, which is a conference. We only had it once here in Milan. The next one is in a few months in Vancouver, and the next one in Milan is going to be in April, around April 2024. And it's a conference about, well, you can read it in the title. It's about the idea of making software that, doesn't suck. But not just from a programming perspective, also from a different perspective. There's a bunch of talks from the last Software You Can Love on YouTube, on my YouTube channel that you can find, so you can see if you are interested in those ideas. Anyway, so before joining the Z Software Foundation and before another job in second to last job, I used to work in a consultancy firm, and I used to do web services. I used to have a stand-up, and I didn't do that job for super long, but I did it for long enough that I wrote some ideas about what I think about stand-up meetings. Now, you can decide if it should count in my favor or be held against me, but Jira retweeted it, so I don't know. Anyway, so let me tell you my daily routine at the time. So 8:55, wake up, make tea. 9 o'clock, stand-up meeting. How long is a stand-up meeting supposed to last? 15 minutes? Yeah, right. So 1 hour later, the stand-up meeting finishes. Let's go on a coffee break. But then a manager starts sneaking in new user stories into the sprint because, there's priorities and it's very important, you don't understand. Okay, fine. 12 o'clock, lunch. 1 o'clock, done with lunch. You know what? Let's watch some YouTube and some Twitch. That was me, not you guys. I know all of you would be working at this point. I wasn't that good. So 4 o'clock, you know what? Maybe we should do some work. But whoops, no, I can't, because the architect is announcing that we are doing event sourcing now. So whatever was in the sprint, now has to be scrapped. So you know what? I'll go back watching YouTube. 5 o'clock, the day ends, and nothing of value was accomplished. Now, this might be, slightly exaggerated. The architect can surprise you with event sourcing only so many times. But you get the idea. I'm sure you have your own version of this. I personally wanted something better. The problem is, okay, how do you do that? It's hard, right? It's not like tech there's a lot of jobs. We get paid well, at least compared to other people. But it's not immediately easy to find, your dream job. So how do you get in a better position? I think there is no silver bullet, obviously, but one thing that surely helps is gaining more competence. Get better at your job. Ideally, you find a better job eventually. Now, what does it mean, though, to get better at your job? Because I don't know about you, but in my bubble, these were the concepts that you were supposed to gain competence about. So you needed to have opinions about CQRS, DDD, or event sourcing, Kubernetes, sagas versus two-phase commit. And everybody had to have opinions about this. But also, and don't get me wrong, I'm not saying that these are bad concepts. Obviously, there's some utility, right? Like event sourcing is super useful if you're doing like orders or like actual purchase orders, stuff like that. And if you're doing event sourcing, then you want CQRS, stuff like that. Also, how many of you, like, raise your hand if at your job you do DDD for real? Like you have 1 hand, 2 hands, 3 hands, 4 maybe? Okay. Nice. I don't hate DDD either, to be honest. I just think that the problem is that with this stuff, like you reach a plateau very quickly, in my opinion. And if you think that this is all the universe, this is what you need to become competent about, you're not going to go very far. And I'm going to explain why I have this stake on these subjects in a moment. But before I talk about that, I'll tell you that, in my opinion, the solution is actually to gain a systems programming mindset, which doesn't even exactly mean that you need to learn systems programming, but it's more about a mindset that a systems programmer normally would develop by doing systems programming. And to give you a very compressed version of what I mean by that is knowing in detail how the system below you work, so that the systems below you work, so that you can make precise use of them to fully solve the use case at hand. There's a talk by Andrew Kelly, the creator of Zig, which is going to be published in a few days, I think in April the 7th, where he gives a full talk explaining this concept much better than this short sentence does. But the point is that not being blind to what's below you really gives you superpowers, or rather, it's really tough if you don't have that. Let me explain you what I mean by that. Because here's the idea: gaining a systems programming mindset helps you also have a much better understanding of high-level concepts. So we are talking about this stuff, right? Let me tell you one huge reason why this stuff doesn't get you that far. How many of you read Hacker News? Okay, nice. So this is me at the top of Hacker News with a Zig post. Not the first time I got there, probably not the last. I'm not saying this just to brag, but my point is there's a marketing angle to all this stuff. And I used to do the job before this one. I was a developer advocate. I was under marketing. What I was doing is not exactly marketing, but let's say close enough. So look at this. Bun is a fast only one JavaScript runtime. How many of you have tried Bun? Has any of you? One hand? Only one hand? Okay, so Bun is a JavaScript runtime. Fine. But look at this is from their website. Look at this. Bun, very big bar. Node, tiny bar. Dino, oof, horribly tiny bar. That's so bad. You don't even need axis, right? I mean, tiny bar, bad. Huge bar, good. But, and I mean, fine, you can believe them, I guess. But oh no, what's that? This is a talk given at a conference by Dino. Let's zoom on their graph. Oh no, Dino big bar, Node and Bun small bar. When the bigger is better, right? When bigger is worse, of course, Bun gets the biggest bar. So who's right? Which of them is right? You don't know. You can't know, because if you don't know what lies beneath, like if you're a JavaScript programmer and you have no idea how these things are implemented, there is no way you can really know which one of them is right. Of course, you can try things, you can benchmark things yourself, and you can get some kind of feeling, right, whether the claims are completely insane or kinda seem believable. But I mean, treating these things as black boxes obviously doesn't allow you to gain a good level of competence, right? Imagine if you were to work as a programmer, but you couldn't understand any piece of code. The only thing you could do is run it and kind of like test it as a black box. That would be insane. That would be horrible, right? So, but that's the situation that you are in if you don't know anything about what's below. You have people selling you graphs, bar charts. This one has axes. That's awesome. But you can't trust them, or rather, you don't have the tools to evaluate them. And then this brings out things like Dino versus Bun performance is rigged. It's easy to win with twice the disposable computing power as your adversary. That's a blog post that was published. And then you have these companies also write blog posts that tell you how you should be doing development. So they tell you, I chose these two ones from Dino because I found them funny. They said the future of the web twice, and I thought it was funny. But I mean, you shouldn't expect anything different from Bun. The future of the web is on the edge. The future of the web is server-side rendering. Can you actually, how can you be sure that these claims make sense? You can, I guess, to some degree. I'm not saying that you know nothing if you don't know systems programming, but there's a hard limit of how much you can know. And the problem is that all these companies have vested interests in selling you a development methodology. These guys do, and well, I'll get to that in a moment. So, but what's the point? Ban raised $7 million in funding by some people. Dino raised $21 million from somebody else. And so, what can they do? The only thing they can tell you, given that they are not selling you the engine, right? Node, Dino, Ban, they're all free. They can only sell you stuff as a service. And you can't expect them to tell you anything other than use more of our stuff. It's like Just Eat, right? You know the full tagline for Just Eat, right? Don't cook, just eat. And I mean, you can't expect Just Eat to teach you how to cook at home. That's not what they're selling. So it's not like they're evil, it's just that's what they do. So let's go back to these things. Guess what? Behind each of these things, there's goddamn companies that have millions of dollars of investment, and then they want you to use their stuff. So they all have opinions about caching. That was my thing. I used to work at Redis Labs. Event sourcing, orchestration, CQRS, clean code. Poor Uncle Bob makes money off of clean code. So again, not that these things are inherently evil. They're not. But the point is that if the only thing you can do is listen to people who have vested interests in selling you shit, you're not going to gain real competence. So I'll tell you, since I have more time, I usually skip this part, but this is relevant since this is a paper we love meetup. I'll tell you my paper story. So I told you that I was at that job where I wasn't really happy, and I was wasting a lot of time on YouTube and Twitch. Yeah, just me. Never seen anybody else do something like that, I know. But I was actually saved by a paper, Cuckoo Filter, practically better than Bloom. So long story short, this was actually a good thing about my job. We needed at some point to deploy a service that needed to handle a bunch of data, too much data to fit on that specific service. And so we looked into probabilistic data structures, which I'm not going to get into today because they deserve their own full talk, which also Guy Royce is going to talk about some. But also, I don't think he's going to talk about cuckoo filters. So if Eduardo wants me again in the future, I'll be happy to give you a full talk about cuckoo filters. Okay, so I'm going to keep quiet on the one cool thing I did with cuckoo filters. Like, well, let's say I think the nicest thing that I did with them. In any case, so I found this paper. And man, this was the exact data structure that we needed to solve our problem. Okay, fine. We were using Redis. Again, I wasn't working at Redis, so I was just doing consultancy, but we were using Redis. So I decided to develop this data structure as a module for Redis. You can add data structures to Redis, which is cool. Problem is you have to implement them in C, and I didn't know shit about C. On top of that, I was on vacation, and I was in Sardinia with this guy sitting there, Felice. We would during the day we would be on the beach. This is like a particularly nice place in Sardinia where you can see there's like three lakes, kind of like, well, it's the sea, Salt Lake, and then the sea again. It's like an interesting conformation. In any case, I would spend the day outside and then go back home and try to code in C, and like it was real tough. So I developed strategies to kind of survive coding in C at the end of the day. And I published the module, and then I got invited by Redis Labs to give a talk at RedisConf 2018. And that was my first time going to the United States. So I gave this talk, implementing a new data structure for Redis as an inexperienced C programmer. And this is actually that slide. I copy-pasted it into this deck. And there's also a couple of slides more from that same presentation. This one is funny. The C compiler will betray you. That was my take at the time. Because it's easy to get into weird problems with C. Also, I abuse macros. So I had a comment that said, what follows is a macro nightmare. Anyway, so there's that. But then, so I couldn't keep control of my C implementation, so I wrote also a Python implementation that they could understand and trust. And I had this, well, this is the Python code, it doesn't matter, but I had this testing strategy where I would basically run the command on Redis, run the command on the local Python implementation, assert that they would both return the same answer, and then assert that the entire memory of the data structure for the two implementations would match byte by byte. That was the only way I could trust this thing to behave correctly. Also because it's a probabilistic data structure, cuckoo filters specifically are also randomized, so there's like stuff going on that it's hard to track. So testing memory, like everything is the same, that was the safest way of, that was the only way I felt like I had a good grip on the problem. Then I discovered Zig, tossed away the Python implementation, the C implementation, and Zig alone, now it's fine. And that's when I started liking Zig, and I started getting involved in the community, and then eventually I moved from Redis Labs to working at the Zig Software Foundation. And yeah, which led to this point, Adio Redis. Okay, that's my story. Sorry, I told you this story because it involves a paper, and also because, I guess, obviously learning systems programming, so in my case, systems programming was important to really appreciate the paper, and it was needed in practice in my case. Obviously, it's not like this exact storyline is going to play out the same for anybody else who's going to learn systems programming, but hey, I don't know. This is how it ended up happening for me. So, getting close to the final part of the presentation. To sum it up, what does system programming have to offer? Point number one, the boring one, performance. So you might be interested in learning a little bit of systems programming because it can make things go faster. You write Python is slow. JavaScript, kind of slow. All these languages, they always have the hardest parts implemented in C or a lower programming language. And here's, for example, this is a SIG-related one because they work with the Software Foundation, but you know, there's an endless amount of libraries for Python, parsers and stuff for Python and other high-level languages written in lower-level languages. That's boring, though. I think if that's what the only thing you could get, would not be worth it. More interesting, and this is, I think, more controversial, maintainability. When you think of C, you do not think of maintainability, I'm sure. But here's an example. H3, it's a thing that Uber invented, so they do a lot of geolocalization stuff, right, with the cars, with Uber Eats, etc. And they decided that tiling the planet with hexagons was better than using a normal grid. They're also lying, because it's not just hexagons. You cannot tile a planet like a sphere with hexagons. You also need pentagons, and there are some in here. But anyway, yeah, they're liars. But it's okay, they came up with this data structure. What do you do at that point? Do you implement, they have to use it in a bunch of different places, right? Mobile apps, websites, internal systems, whatnot. Do you implement the same data structure 1,000 times and then have the problem that it's always going out of sync and different things are diverging and you have weird bugs? Works on my platform, right? Better than on my computer, still not great. What you can do that's strictly better is write it only once in C. You can see here 93.3% is written in C, and then you make bindings for other languages. And yes, you definitely take a hit in maintainability because the damn thing is written in C rather than your favorite programming language that doesn't have segfaults. But at least it's one for all these ecosystems. And it's much easier to keep a grip on the thing that way. Point number 3 is reliability. This is another interesting story that touches upon a couple of papers. So there's these two papers called use-stamp replication. It's the same protocol, just first paper, second paper on it. These are consensus protocols. This is a consensus protocol, just like Raft and Paxos, if you heard about those. Those are the protocols that basically make sure that distributed databases and, yeah, let's say distributed databases stay consistent when it comes to, well, yeah, distributed data. Use-stamp replication is the least famous of the three. Raft is famous because it's easy to implement. Paxos is famous because it's supposed to be faster than Raft, more efficient. I think if you implement all the things that can make it faster, but it's more complicated. And then there's also use-stamp replication that they're all kind of the same. they actually all kind of the same. But in any case, this consensus protocol is used by this distributed database, Tiger Beetle. What's interesting about Tiger Beetle is that while they're using this consensus protocol, it's a financial database. It's like a oh my god, man! It's an accounting database with oh god, I forget the name of the 2-entry thing. You know when you have inputs, outputs, huh? Yes. I forget the English name though. In any case, it's a financial database. It's a very purpose-built for one specific domain. But it's also very heavily tested. It's an interesting database. Also, this was on the top of Hacker News today, if you care to read it. But here's what's funny. I had an online, on my stream, you can find it also on my YouTube channel, an interview with the Tiger Beetle people and the authors of the original 2 papers, Dr. Oki and Dr. No, Barbara wasn't there. No, James Cowling. That's the first authors of the 2 papers, not Barbara. I think I was told she couldn't make it, but would have been fun, nice though, yeah. In any case, we did this, and here's what's interesting about Tiger Beetle, okay? So you like the distributed consensus papers, and you read them. Reading papers is interesting, but you can take it to, if you know how to implement this stuff for real, you can take it to the next level, because there's really a next level of enjoyment when you actually know how to implement the thing. And in particular, Tiger Beetle is taking reliability to the next level, where they don't just get the consensus right, but they also have, as part of their fault model, on-disk persistence issues, like, for example, writes that fail, writes that get misdirected, stuff like that. And they also do not do dynamic memory allocation. That's funny. So basically, the database boots up, allocates a bunch of memory, 4 gigs, I think, more or less. So it's not like they allocate a timeout. It's 4 gigs. But then, that's it. That's 4 gigs. They don't dynamically allocate anymore after that. So long story short, the database, if it boots correctly, it cannot crash, cannot go out of memory and be killed by the killer. So I think that's a very interesting property. And if you think about it, I don't know, for example, I do video editing on my computer occasionally. Every single time I do video editing, I know that Discord is going to kill itself and Firefox as well is going to crash. Every single time, because they keep dynamically allocating memory, and the video editing software consumes all the available memory when rendering, and so no more memory is available, and these things always book themselves, which is annoying. So so I think there's a genuine, like, it's genuinely useful to be able to make software that just doesn't crash like this. I understand that maybe your employer isn't worth that level of effort. Fine. but I think, you know, if you like the craft, it's interesting, the idea of saying, man, I wish I could make software that wouldn't just crash randomly. I mean, like, we all use Windows, I suspect. One way or another. That's another example of software that doesn't behave like it should. But this is also true when it comes to distributed systems. If you think about it, because maybe you don't do desktop, you don't make desktop applications, fine. But think about it from also a distributed systems perspective. When you make software, your software, and you ship it to Kubernetes, Kubernetes needs to know how much memory, how many resources are needed to spin up an instance of your program, right? So that it knows how many of these things it can put on a single physical machine, right? And the problem is that if your software has dynamic allocation all over the place, memory consumption fluctuates. You can have an upper bound, but if you're too conservative, you're wasting resources. And if you're too aggressive, then the instant your software is a little bit under stress, you know, maybe the GC has not run yet, it will run soon, but for now memory consumption is ballooning, then the system goes out of memory, everything crashes. Which could be worse, because just like it was spun up, now it crashes, and now Kubernetes can spin it up again. But again, maybe your employer is not worth the effort, but it's nice idea that you can make software that just is that reliable. And In this case, for these people making databases, for them it's actually a necessity. Fourth point, which I already hinted to earlier, is that I believe that learning a little bit of systems programming can help you fuel real growth. Because you can escape the bubble where everybody has very nuanced opinion about DDD and clean code, so they're like sommeliers. This code is kind of clean, but I can smell it's, it's fruity, it's flowery, but it's not clean enough. It's not real clean code unless it comes from the French region of blah, blah, blah. But seriously, I'll give you one example. Again, I'm tooting my own horn. I'm aware of that. And just so you know, nobody cares about this library. But I'm personally really happy with what I did because you can find a ton of cuckoo filter implementations on GitHub and on the internet, but they are all implementing what's written on the paper. They never go past what's written on the paper. And the paper only tackles the computer science aspect. It doesn't tackle the full software engineering problem. So I'll read you a piece from my README. Most cuckoo filter implementations available on GitHub get the computer science aspect right, but fail at the engineering level, rendering each basically unsuitable for most serious use cases. These problems go from not offering a way to persist and restore the filter, kind of important, right? Might want to be able to write, to save the damn thing and get it back out from disk, up to silent corruption of the filter when its fill rate increases too much because implementation has no vacant /omelette slot. Like, you can misuse cuckoo filters and you break them, meaning that they don't hold the original properties. Like, they don't give you good answers anymore. And most implementations don't deal with this use case because the paper tells you that this is a problem, but it's obviously not offering you an implementation on how you should design a good developer experience for the users of your library, where they can be protected from foot guns and also be warned when something bad happens. So this implementation covers all these aspects in full, giving you complete control over the filter while making sure the misusage gets always properly reported. And I felt pretty good being able to do this. And again, this is something that exists, if you will, it's a different way of enjoying the paper that goes past reading it, because implementing it can be pretty cool. One last thing that I think systems programming can offer you is more in general freedom. I am sure that everybody here has had to deal with dependencies that are janky, broken, but you can't replace them. But at the same time, you don't know how to fix them because they maybe have a C++ implementation, they are a little bit too low level and stuff like this. And so you feel trapped, like you feel a prisoner of your ecosystem. If you dare to go beneath the water level, you can achieve real freedom because now you can't be stopped by a janky dependency. Of course, there's limits. You're not going to be able to, I don't know, rewrite your entire OS in a night. But there's a real difference in perspective that you can gain once you dare opening your dependencies and going past them. One last point, which I think is actually very important, is that you heard me mention about how problematic and annoying C has been. I still believe it is, and when I was in university, I remember kind of thinking that I had two roads in front of me. Either I could learn all the web development bullshit or all the C low-level programming bullshit. I went for the web development bullshit. I don't regret it. And for a long time, I felt like the systems programming bullshit was way too much friction for what I would gain in exchange. And I don't think I was wrong at the time. I still think it was a reasonable choice given my, trajectory in life. But the equation is changing. The equation is changing a lot because systems programming is becoming cool again. In my case, when I discovered Zig, again, before joining the Software Foundation, when I first discovered Zig, for me, it felt like a cheat code to learning systems programming while also bypassing a ton of like bad accidents of history, a lot of annoying idiosyncrasies that exist in the C ecosystem. And if you don't like Zig and you think it's still too niche, fine. Rust is another great example of a systems programming language that's gaining traction. And there's also more. It's not even just these two. So my final point is, think about it. The equation is changing, and it's making systems programming much more viable to pursue as an interest. And that's it. Thank you.
Are there any questions?
No complaints about the clean code joke?
Or the web bullshit, but you balance it nicely with the system bullshit. So. I do have a question.
Yeah.
In the meantime, let's see if then someone else comes up with their own. So, so you showed a lot of examples of why it is useful to do lower level programming, systems programming, and why it is interesting. One question I may have is, in my daily job, I may not have that that chance to do lower level programming, but I guess there's a lesson to be learned here in your talk, even if I'm doing higher level programming. So how would I be able to apply your suggestion, even if I'm not able to do that that low, that close to a system?
Yeah. Yes, in my case, I was definitely very lucky being, being allowed, tricking my workplace at the time to allow me to write a Redis module. I didn't trick them. I don't know. I convinced them, I guess. I actually was in cahoots with the architect. That's the secret truth. But it is true, I guess. So in won't probably make a difference for most people, but actually if you're able to negotiate this kind of stuff at your workplace, there might be a tiny chance that maybe you occasionally can sneak in something close to this. So, being able to have this kind of interactions in a positive way in your workplace can truly make a difference. But yeah, for most people, this won't be an option. My suggestion is, there are hobby interests that can get you closer to lower level programming that are very nice, and those go from embedded devices like programming a Arduino device, Raspberry Pis. In the Z community, we have people working on this kind of stuff. It's pretty cool. Mechanical keyboards, man, they're so cool. And the software stacks, they suck so much. I don't hate QMK. I just hate the tool chain to build QMK. It's disgusting. So you can get more familiar with these things. Maybe game development, and game development doesn't have to be, necessarily the crazy, let's learn how to do OpenGL or worse, Vulkan from scratch. It's going to be a nightmare. You can also do some very funny things where you're programming for fantasy consoles. For example, there's one called there's Pico 8, and there's another one for WebAssembly. Yeah, WASM4, thank you. Which are fantasy consoles. So the WASM4, I think it's amazing. So it's a WebAssembly, fantasy console that acts as a runtime for you. It's like the screen is bicolor, I believe. A very low resolution. It's like programming for an old Game Boy in a sense. So the nice thing is that by having a ecosystem that constrains you a lot, it kind of helps creativity, because you have to get creative with making things work out, and there's a much lower chance that you can get lost into rabbit holes. You can actually make things happen, simple things, not super complicated things, but you can make them happen. So all these things can give you an opportunity of learning something about systems programming. Today, I guess, coming to this event was also maybe an opportunity for you to get introduced to the idea. And there's also Software You Can Love. It's another conference where we have a full Zig day, for example, where we talk about systems programming. And then the second day, it's the actual main day of the conference, where we talk about more high-level concepts like, does technology destroy art, or stuff like this. So yeah, and more in general, I guess, joining a community that's centered around this stuff can help you get in some practice. Yeah.
Yeah, I know. Last time that at the meeting there was someone bootstrapping a community for embedded programming. I don't know if they are. Oh, he's here, so you can talk to him too. So.
Yeah.
All right. Are there any other questions? Okay.
The main point I got from this presentation is that there are many advantages from learning system programming, so you can go under the hood and tweak things your way if you need so. But do you think there are also advantages when learning system programming that you can use while programming at eye level, like patterns or something that, oh, I know this works like this underneath, so I can use this Java function differently, or I don't know, something like that.
Yeah, for sure. I think that it's if you only know high-level programming, I think you are subject to two problems. One is that you're straight up get lied to by people who have an interest in selling you something. So they will sell you development methodologies, and if you know what's going on behind the hood, it's easier to not get addicted to frozen meal development methodologies, clean code, which is, by the way, they're not necessarily bad, right? But you can, in my opinion, you can gain a level of competence where you get past all kinds of frozen meal development methodologies, and you can appreciate what there's good in what they say, but also go past that when necessary. Like one example, dry, don't repeat yourself, right? It's really good. It's really, really good, right? You want to have one source of truth for a piece of configuration, for a piece of functionality. You don't want random duplication. At the same time, I can tell you that working in the Z compiler, which is a pretty serious project and piece of technology, we have copy-pasted functions all over the place because we avoid over-optimizing this stuff before we know when it's actually a good idea to do so or not. And it's tempting to say, oh my God, I see these patterns repeated, I could collapse this thing in a function. But if you're not sure yet, if you're not yet at that point, then going dry right away can be, if you will, a form of premature optimization. It can be a problem. So long story short, on one end, I think you can gain competence to the point where you get past these things, like past these frozen meal ideas. But the second point is that if you only know high-level programming, for you, there might be no difference between, for example, a for loop versus a for each. And there might be big implication between one way of expressing the thing versus another. And that also connects back to ways of developing software, because maybe if you have no idea what's going on behind the hood, so when you have a thing that needs to send a message, should component A send a message? Should component B receive a message? Should there be a message sender thing that produces messages? And people start going up with these castles of thought where they imagine, maybe by thinking of DDD or some other very abstract development methodology, they start thinking of abstract ways of structuring things, because to them everything is the same. Well, if you know what's going on behind the hood, you can actually have a preference for one style versus another for genuine practical reasons. And so it's like you have a thread that connects you, if you will, to reality, connects you to to what the damn machine is doing. Because if you don't do that, you end up with garbage, like, for example, if you're aware of RAI, R-A-I-I, that's this system where, for example, C++ uses heavily, where objects, classes, have a destructor. So whenever the class is about to be deallocated, runs its own destructor. And that's one reason why if you use for stuff like Visual Studio and you close it, it takes like 30 seconds for the thing to close. And like, it should be closing, right? Why doesn't it just close the damn thing? The answer is because every single object in the system is deallocating itself in very fancy ways, while in reality, what the system could do is actually make sure that all the files are saved, and then just call the exit syscall without even freeing memory, because it doesn't matter. The OS is gonna clean up memory anyway. So these are like concrete things that you can think about that, in my opinion, should outclass completely all kinds of DDD sommelier way of thinking. But you can't know which is which if you don't know that exit is a syscall, for example.
So you said that basically the equation between system programming and high-level programming is changing as if you were a student now, maybe you would make like a different evaluation on that. Do you have like a rational explanation on that? I'm on the same side because I enjoy embedded programming, system programming, all of that. But like from a business perspective, still jobs and opportunities, there are probably still a lot more on high level.
Yeah, no, for sure. Yeah. No, I agree. Like from a career perspective, web shit all day, all the time, no doubt. That's definitely the way to go. Systems programming, this is interesting because I had a similar discussion with people in another community called the Handmade Network, who are people really focused on like rethinking software engineering from the ground up, like reinventing the wheel, because they really hate what I just described, like Visual Studio taking 30 seconds to close, and I agree with them from that perspective. But what's funny is that while on one hand they complain that they wish more people cared about the details to the same degree that they do care, on the other hand, it's true that the financial incentives are not there yet at all. So like the vast majority of jobs are web development jobs where the details don't matter. Like your employer doesn't want you to think about the details. They want you to kind of make the thing work as fast as possible because they're telling you you're doing agile, but they told the client they actually sold them a fixed amount of a fixed amount of development hours, whatever. So they're doing this kind of weird shit. No, I don't think that that from a job perspective anything has changed. What has changed, in my opinion, is the amount of effort that you have to put into systems programming to learn some systems programming. Now, it's much more accessible, in my opinion, than before. We're not yet at the peak. We are very far from the peak, but all these new languages are making it much more accessible. And I personally use Zig as a cheat code. Like I really felt it was a cheat code to learning what matters about systems programming, what matters about computers, without being lost into the insanity of C and C++.
Any other questions?
So actually, almost on the same note, I was wondering. So if I understand correctly as well, is like we are saying, well, for the business logic, somehow the higher level, sort of like web, so oriented, those are more appropriate, and looking for opportunities to indeed cheat code into system programming, say, learning Zig, because indeed it could be an opportunity to delve deeper. So in this so I think if I understand correctly, sort of like the advice, that resonates a lot. And one question that I have on this tangent is that I'm seeing recently with this hype of ChatGPT, a lot of discussion about replacing the developers.
Yeah.
And what I mean by that, so first of all, I'm very interested in the technology, but I don't buy that much into the hype. But what I found most interesting is like recently they've been showcasing, I want to have ChatGPT to suggest me a full web app. So sort of like do a React and then do a little bit of CSS. And actually, it looks like it's working really well. So in these regards of like looking for new way of growth, I was wondering if you tried something like this, like a ChatGPT to suggest some Zig code, and how good it is, or hopefully how bad it is, and what you think in the future could be like the approximation that the systems can help you on this type of system level.
Yeah. Okay. So I can tell you a bunch of hot takes about ChatGPT. Okay, I'll be very quick. As a starting point, how many of you have tried ChatGPT? Okay, cool. So here's my take. It's awesome. It's way better than the chat box. What I find really surprising about ChatGPT is not the answers that it gives, but rather that it always understands what you mean. And I used to joke when stuff like Stable Diffusion came out, that you should add a prompt mancer to your CV, because getting Stable Diffusion to create images like you wanted them kind of required prompt mancy, as in like you need to structure a prompt in a way that works, but there's like no real reason why the prompt has to be like this. It's just not all a artifact of how the neural net was trained. I mean, not entirely, but it was a little bit prompt-mancy. When ChatGPT came out, my take was that, okay, prompt-mancy was born and dead right away, because now the thing really understands you. You can obviously ask the thing in better or worse ways, just like you can with other meat-based intelligences. So not every question is, there are better and worse prompts, but I find it really amazing how good it is at understanding you. Now, the problem with ChatGPT is that all it knows how to do is confabulate, which is an interesting word, because it's a very old word and describes perfectly what ChatGPT is doing, which is pretty much the same thing that you do when you're dreaming. You know, when you're in a dream, and there's like weird things happening in your dream, but for you they're fine, right? You don't have, like, the critical part of your brain is still asleep, so things work in a weird way in your dream, and you just take it for granted and roll with it, right? That's kind of what ChatGPT is doing. So I've tested it with like a few logical things, and it kind of follows along, but it clearly doesn't have, it has the half of the brain that comes up with stories. It doesn't have the half of the brain that understands math yet, but now it has plugins, so that's cool. So long story short, I think that the people who should be worried about losing their job are like people working help desk jobs, like quote unquote low tier, user assistants where the user is annoying as fuck, and maybe the help desk team was even abroad. So like here in Italy, it happens that you have the help desk, like the help team be from abroad, and I don't mean this in a racist way, but if you think about it, it's like there used to be this thing where they would kind of explain what the problem is, what the possible questions are, what the corresponding answer should be. They kind of explain them, and the agent, on the other hand, kind of understands them and kind of makes those work with when on a call with the customer. And now, instead of being somebody who doesn't fully understand your language, it's ChatGPT, and the result is kind of the same. So except it's less expensive. So these are the poor people who I think are going to lose their job first. Can you lose your job as a software developer? I think not with ChatGPT 3, not with ChatGPT 4, but who knows? Maybe they'll get there. I mean, what it does, it's already pretty interesting. And my real answer is, I think ChatGPT might eventually replace you if you don't learn systems programming. because for jobs where the thing has to kind of work and not be really done well, I mean, your mistakes, or rather, not necessarily your mistakes personally, but the artifacts and the mistakes introduced by the, insane theater of trying to make it look like we're doing agile, but we're not really doing agile, and the stakeholder in the project is kind of weird and on weird drugs and nothing makes sense. They can also make that happen with ChatGPT. They might at some point also be able to make that happen with ChatGPT. So start learning systems programming for real. That's it.
I think one of the tricks for the Zig programming language and ChatGPT is that the compiler changes so fast that ChatGPT cannot keep up.
In the specific case of Zig, ChatGPT is always giving you actually a Rust, basically.
So, any other questions? All right. Okay, so I think we're good. So let's give another round of applause for the audience. And let's thank a bunch of people. Let's thank Matteo for for directing the live stream. Let's thank Daniele for helping with organizing. Let's thank Luca for his help and coordinating the eDreams Tech Lab, and obviously all his colleagues that contribute to this. And let's thank them also because even tonight they are offering food and drinks. So let's give them another round of applause. If you still don't know, they're hiring quite a few people. There's a QR code on the wall there, and I invite you to check it out. Maybe
apply before ChatGPT becomes too good.
Exactly. All right. Thanks, everyone.
Quindi dirà che sono birra, ma